All right, so 1.5 was the last section that we covered before your test. 1.5 was all about your combined and composite functions, so adding, subtracting, multiplying, dividing. And then the f of g and g of f. And then the rules for domain we talked about, okay? These are all from an algebraic expression, but remember the last question was the graphing one. You're going to see something like that on your test as well. So you won't see all of these on your test, but you'll see a couple of them. It says find the following and include the domain restrictions. So for number 1, you're doing f plus g of x. You're literally taking and adding the two expressions together. So 3x minus 1 plus x squared minus 4. And then you want to see if you can combine like terms. There are terms to combine this time. X squared plus 3x minus 5. You can leave it in any order. Like obviously, typically if it was a multiple choice question, they would put it in decreasing degree order, but it's okay either way. Then you have to look for domain restrictions. So when you're adding, subtracting, multiplying, or dividing, remember you have to look at both originals and then the combined one. So if I go back to the originals, is there a domain restriction on the f of x? No, this domain would be negative infinity to positive infinity. Is there a domain restriction on the g of x? No, this would also be negative infinity to positive infinity. Then you want to look at your new function, which for f plus g was this. Is there one that we introduced? No. So domain restriction for this does not exist. It is all real numbers, okay? F minus g, I'm going to take the f, which is 3x minus 1, subtract from it x squared minus 4, making sure I distribute that negative to both. So negative x squared plus 4. Combine your like terms. Negative x squared plus 3x plus 3 this time. And again, it can stay that in any order. Is there a new domain restriction introduced? No. So again, negative infinity to positive infinity. Then I get to f over g. With f over g, I'm putting f over g. There's no simplifying needed, okay? Is there a new restriction brought in this time? Yeah, what's happening? Good. So our x squared minus 4 cannot equal 0, which means x cannot equal negative 2 or positive 2. I could have either factored that or used the even root, but either way you should get plus and minus 2 is what it can't be. Which means my domain is going to be from negative infinity to negative 2, negative 2 to positive 2, and 2 to positive infinity. That whole thing would be my domain restriction. Questions on that one? All right, so then your f of g and g of f, or your composite functions, the domain restrictions work a little differently. The domain restriction comes from the one you are plugging into first. So whatever's on the right, g here or f here, if there's a domain restriction on that one, we have to carry it down, but we don't have to carry down the other one. In this case, it doesn't matter. There's no domain restriction on the g of x, so it doesn't matter. But if I took g and I plugged it into f, I would have to ask also, would there be a new domain restriction there? If I plug that in, it's not putting it into the denominator. It's not doing anything like that. So there is no new domain restriction. The domain on the f of g is still going to be all real numbers. And then you have two choices. Take this expression and plug it in there. So it'd be 3 times x squared minus 4 minus 1. Distribute the 3, combine your like terms, and then plug in the negative 1. Or what I would recommend is do g of negative 1 first. So I go to g, and I plug in negative 1. Remember, when you plug the negative into the square, the negative stays in the parentheses. So that becomes a positive 1 minus 4, which is negative 3. And then I'm going to find f of negative 3. So then I go to my f function, and I do 3 times negative 3 minus 1, negative 9 minus 1. Negative 10 is the overall answer there, and there is no domain restriction. It usually will not ask for a domain restriction when there's a value there, but it could ask it when it's being plugged in, so that's why I just added it so we could review that. Is that your question?
Yeah.
Yeah.
Is writing it like that the same thing as writing it like F and then the circle of G?
Yep.
Okay.
Yeah, these two symbols mean the same thing. Obviously, the order is different there. But F of G with an open dot is the same thing as F parentheses G with a, whatever the value is inside. So 5, this is the same thing as saying G of F of -2. So I'm going to first go to F this time. If there was a domain restriction, I'd have to pull it down. There's not. So I can plug it into F. I would do 3 times -2 minus 1, -6 minus 1, which is -7. And then I take that and plug it into the G. So I do -7 squared minus 4, or 49 minus 4, which is 45. And again, if I plug F into G, the other way around, okay, I'm not bringing in a new domain restriction. There was none to carry down from the F. So the domain on that is still -infinity to +infinity. Questions? So you're going to see questions like these, and then you're going to see ones that involve the graph, like that was in the homework, where you had to use the graph to find the composite or combined functions. Questions? Questions on homework? Okay, good. All right, we're jumping into the review note. So I post it to you as a note file so you can move things around or edit whatever. If you don't like my handwriting, feel free to erase it and rewrite your own. But I give this to you just so that we could do this in a little bit of a quicker pace than if you had to write down every single little thing. All right, so I'm going to go through the formulas and stuff you need to know, some examples of stuff you need to know. Now, not every single thing that's on this is going to be on your test. Just for time purposes, I had to cut some stuff, okay? But you need to review and be prepared for all of it. In C1 and C2, I really try to cut back, especially C1. C1, you really only need to know your distance formula and your midpoint formula, okay? And more in an application-based question, not what is the distance and what is the midpoint. The formula for distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. It's got to be a simplified radical. So you won't approximate. If it said like square root 20, you would make it 2 root 5. You keep it exact, but you do make sure it's simplified. Then came the midpoint formula, which is x1 plus x2 over 2 and y1 plus y2 over 2. And this stays in coordinate point form. C2 was where we got into the graphs with intercepts, symmetry, that kind of stuff. So if it asks you for the x-intercepts, you're going to plug 0 in for y and put it in coordinate point form. If it asks you for the y-intercept, you're plugging 0 in for x and giving that answer in coordinate point form. There can be more than one. So like if you look back on your quiz, that question was the one that had multiple parts, okay? These are the ones where there's a good chance you have to factor something to find out your intercepts. And then it's going to ask you to test for x-axis, y-axis, and origin symmetry. The rule on x-axis symmetry is we change the y to negative y. Y-axis symmetry, we change the x to negative x. And origin, you do both. X to negative x, God bless you, and y to negative y. And if it simplifies to the original equation or every term changes sign, then it is symmetric to whatever test you just did. God bless you. If you're looking from a graph, x-axis symmetry would be one in which I folded at the x-axis, it would overlap, like a sideways shaped parabola. Y-axis, if I fold it on the y-axis, it would overlap like a regular parabola. And origin would do both. Whatever's reflected in the top right would happen in the bottom left. So you could fold it top to bottom and then left to right, or the other way around. Whatever's happening in the top left would reflect in the bottom right. Now you can have origin by itself. You can have x-axis by itself. You could have y-axis by itself. If you have both x and y, you automatically have origin. And remember, that comes back again when we talk about even and odd. Okay, so symmetry, y and origin, you could see twice by way of that. All right, then came finding the equation of a circle given the endpoints of the diameter. So you guys on your quiz had midpoint, or had the center and a point on the circle. Test-wise, you'll see it this way. This really tests, so you're not going to see these and this. It's going to be the circle question that basically requires those skills, okay? Because if I give you the endpoints of the diameter, then first of all, you need the equation of a circle, which is x minus h squared plus y minus k squared equals r squared. So if I gave you the endpoints of the diameter, what would you do with those? What do you have to find first? Before you could do that, well, you could do it the long way, which is distance between the 2 points, cut it in half to find the radius. I will warn you right now that that's where people make mistakes, because when you have a square root and they have to cut it in half, people do it wrong. Like, you have to simplify the square root. You can't divide 2 into the square root, and that's where people make mistakes. So what's your other option? Midpoint. Find the midpoint, which is what? What does it double as in a circle with the endpoints? The center. So I'm going to find the center using the midpoint. And then what could you do? Once you find that HK? Do the distance. Plug in or find the distance between an endpoint and the center. I would recommend just plugging them in. So, because it's been a little while, we're going to work through one of those. So the first thing you're going to find is the center, and that means it's the midpoint between the endpoints of the diameter. So 5 plus 7 over 2. And negative 3 plus 1 over 2. And I get 12 over 2, which is 6, and negative 2 over 2, which is negative 1. That's my center, so that's going to be my h and my k. Now, again, you could find, to do the radius, you could find the distance between that point and either endpoint, but then you're going to have to square it to put it back into the equation, which is fine. It works, but it's one extra step. Or you can grab either of the coordinate points, and I would definitely recommend grabbing the one that doesn't have a negative if that's an option. Make that your x, y, make this your hk, and plug it into your equation. So 7 minus 6 squared plus 1 minus a negative 1 squared equals r squared. 1 squared plus 2 squared, 1 plus 4. So your r squared, which is what goes into the equation, is 5. And then you take and plug back in just the h, the k, and the r squared. And I would say be very careful there, because mistakes made are plugging in an xy instead of the hk. Okay, then we got into 1-1. So those first two sections, what were on your quiz, then we got into 1-1, which is the graphs of lines, the slope of lines, all that stuff. Okay, you obviously need to know the 3 forms of the equation of a line. The most common, and the one that you will answer in unless you're told otherwise, is slope-intercept, which is y equals mx plus b. Point slope, which is what you can plug into if you're finding the equation, which is y minus k equals m times, why not y minus k, sorry, brain's still in circles. Y minus y1 equals m times x minus x1. And for that one, you would plug in your point and you'd plug in your slope. And then standard form, which you can easily get the slope out of, which we'll talk about in a second. And if it says put your equation into standard form, you want to put it back into standard form. No fractions or decimals. X must be positive. So that one, if you have a fraction or decimal, you're going to get rid of it anywhere in that equation. And then the x has to be positive. X and y are on the same side. Y can be negative, c can be negative, but the x has to be positive. It could ask you to find the slope of two lines. This is the y2 minus y1 over x2 minus x1. The symbol is m. And from standard form, it's negative a over b. So that's the shortcut if it's in standard form. What's true about the slopes of parallel lines? Same slope. Good. What's true about the slopes of perpendicular lines? Opposite reciprocal. So the kind of question that puts it all together is the one at the bottom here. Find the equation of a line that passes through negative 5, 4 and is A parallel, B perpendicular to a line with the equation 7x plus 2y equals 8. And there's two parts. So A is where they're parallel and B is where they're perpendicular. So the point I'm going to use for both, but the equation that it gives you, I need to pull out of that is slope. What's the slope of 7x plus 2y equals 8? Negative 7 over 2. Remember, negative a over b is the shortcut. If you forget the shortcut, then you got to solve for y. It's still fine. Just takes a little bit longer. So the slope of a line that's parallel to it is going to be the same. And then I'm going to use the point negative 5, 4. And then the slope of a line perpendicular to it is the opposite reciprocal. So I flip it and change its sign. And I still use the coordinate point negative 5, 4. With me so far? Yeah? All right, then I plug it in. Remember, you can plug it into y equals mx plus b, solve for b, and then plug that back in with your m. Or you could plug it in point slope. So I'll do one of each. Point slope would be y minus 4 equals negative 7 halves x minus a negative 5, which is plus 5. Then I'm going to distribute that negative 7 halves. And I get negative 35 over 2. Then I'm going to add the 4. I have to give a least common denominator there, so I have to put it over 2, which means this turns to 8 over 2. And I get 27 over 2. Don't waste your time putting that into a mixed number. Leave it how it is. It needs to be simplified, but it can totally be a mixed number. I mean, it can totally be improper. That's where you need to save yourself some time. Questions on that one? So here's what you don't do from A to B. You don't pull over the B from A. It does not overlap, and that's what people make a mistake of doing. They are two separate equations. The only thing you're using the same is the coordinate point that got given at the beginning. Now I'll do point slope so you could see, or slope intercept so you could see the difference. Now this is my x, this is my y, so it'd be 4 equals 2/7 times x plus b. 4 would equal negative 10/7 plus b, and then I add the 10/7. 4 over 1 becomes 28 over 7, and b is 38 over 7. Then I plug back in the m and the b. You get to choose which method you use. Obviously, whatever you're the most comfortable with. I kind of doubt you'd have time to go back and check, but if you did, you could always go back and do the other method. All right, then came 1, 2. This was identifying functions from a graph, from coordinate points, and from an equation. Actually, from a graph came next, but I just looped it in. Okay. And then the piecewise functions we evaluated in 1, 2. We graphed in 1, 3. I pulled them together because that's what the question's going to look like. Okay. And then we did domain. Okay. So at the top, if you're identifying from an equation, if I just gave you an equation and said, is this a function? Then the answer is yes, unless the y is raised to an even power or the y is an absolute value. If the x is, it's totally fine. The problem is if the y is. So if a parabola is turned on its side, it is not a function because it would fail your vertical line test. So if you think about later, we brought in the vertical line test. This would also can get used to check to see if it's a function, okay? The vertical line test. It's just that you don't want to have to worry about what does this graph look like. You want to be able to look at that equation, and should be a 10-second question. If y is raised to an even power, it's no. If it's not, it's yes. Okay? If it's put in absolute value, it's no. Otherwise, it's yes. Then it comes, and I did it kind of just like this. There's going to be a question where you evaluate your piecewise function, and then right next to it, it says to graph the piecewise function. So the evaluate, remember the value of x determines which range it comes from. So if I look at A, 0 here would fall in between -2 and 1. So I'm plugging it into that one. I'd get 0 plus 1, which is 1. 3 would be greater than 1. So I plug it into x squared minus 1. 3 squared minus 1 is 9 minus 1, which is 8. Then it's going to ask you to graph it. And remember, there was 2 options here. You can either plot points from within that range, or you can draw the whole thing out and erase what you don't want. So if I start with the top one, what kind of graph is y equals 3x minus 1? A line. So I'm going to start where? -1, do it in the right color, -1, and then I'm going to use my slope to go up 3 to the right 1 or down 3 and to the left 1. Now I don't want that whole line because I want it to start where x is -2. So really down 3 and to the right 1, I want that point to be an open dot and I want to point left of it. And then I would erase everything else. Teeny tiny eraser. There we go. And that should be an open dot because it's not or equal to. Then my next range is x plus 1. So this is a line starting at 1 with a slope of 1. Up 1 and right 1, down 1 and left 1. And this is going from where x is equal to -2 and stopping where y is 1, but it doesn't include it, so it gets an open dot. No, sorry, it does include it, so it gets a solid dot. Those are both or equal to's. And then the last one, what kind of graph is x squared minus 1? Parabola, where x is greater than 1. So if I now know, because when we did this, we didn't review all the transformations, then we did, so we would know that that x squared minus 1 is a parabola that is what? Shifted in what direction? It's after the function, right? It's not inside the parentheses, which means down. So it's shifted down 1, and then you'd go up 1 into the right 1, and it would look like this. But and obviously it would go back the other way, this way. But I only want it for where it is greater than 1, not even equal to it. So I would erase everything to the left of 1, and I would even make this an open dot. The other option would have been to plug in those points. If I plugged in 1 squared minus 1 is 0, I got the point that I have open. And then if I plug in 2 squared minus 1 is 4 minus 1, which is 3, I would know to plot my point there. So if you're unsure about your graph is supposed to look like, you can always plug in some points. And remember, there should be no solid dots vertically aligned with each other because it would fail your vertical line test and it wouldn't be a function. These are functions. So where x is -1, there's one solid dot, but then there's one open dot. And where x is +1, or -2. X is a +1, it's solid dot and open dot. Xavier.
Can you explain the blue one again?
The blue one is I started with this one. I started with a y-intercept of 1, right? And then my slope is up 1 and to the right 1 or down 1 and to the left 1. And it goes from -2 to +1 with a bracket on both, or solid dot on both because it's or equal to. So I just kept going in the direction with the slope. And then the endpoints are both solid.
There was 4 dots. I didn't see the 4 dots.
Oh, yeah, sorry. I just kept going with the slope. All right, then comes domain from an equation. So it is all real numbers, or -infinity to +infinity, because we're going to give this in interval notation, okay? It is -infinity to +infinity unless there's a variable in the denominator, and for those we set not equal to 0, a variable under a square root. We set that greater than or equal to 0, a variable under the root and in the denominator, and we set that whatever's under the root greater than 0. And remember, if there's more than one, we have to see where they overlap, right? It's an and statement. It can't be this or this. So it's an and. It can't come from this range, and it can't come from this range. We would overlap. And if that requires a number line with shading, do it, okay? But there could be an overlap domain.
What does it say? Right next to the except the TI.
It's like the double arm is just all real numbers. But you'll give it an interval notation. So it'd be -infinity to +infinity. All right, then came the difference quotient. Again, you needed to memorize f of x plus h minus f of x all over h. If you do your review tonight, tomorrow, whatever, whenever you get to the difference quotient, there's 2 of them on there. This pattern should have sunk in. Like the steps are the same every time. So if you did it with me during notes, you did it on the homework, you did it on the warm-up, and you do it on the review, your body should innately know how to do it, okay? Just don't mix up your signs. That's the mistake people tend to make here. It is f of x plus h minus f of x over h. And remember, things should cancel out. If they don't, you did something wrong. Okay, then came functions. This is the big graph question. You're going to get your calculator question first. It's going to ask you to graph a function and then answer a bunch of questions based on it. The first being domain and range. Remember, we read this left to right and then bottom to top. It is in interval notation. Then we'll do increasing and decreasing and constant behavior. There's going to be a line for each. And if one of them doesn't exist, you would just write none or NA or DNE, something to let me know you actually answered that question. And for the increasing, decreasing behavior, remember we give the X values. I would say that's the biggest confusion for people. You're giving what values of X. It is increasing, decreasing, and constant. The zeros are where it crosses the X axis or where f of x is 0. You have to know how to find the 0 from your graphing utility. You are giving just the X value, so that is not in coordinate point form. Then will be your relative max and mins. This could be more than one. The max is every peak and the min is every valley. These are given in coordinate point form. Even and odd, by looking at your graph, it is even if it's symmetric to the y-axis, and it is odd if it's symmetric to the origin. Remember, O for odd and O for origin. And then finding the value given in X. You would just go to your value menu on your graphing utility and plug in that value. Pretty much everything on this lives in that little calc menu on your graphing utility. I put a question over the weekend that like has it all on there. If you want to practice that one, there's another one on your review. Okay, so if the graph and calculator is where you feel the shakiest, then definitely focus on that this evening so that it doesn't get you. And you don't want to take a lot of time on it. The more time you take on this, the less you have for the rest of your test. So you will start this. So on Thursday, when you come in, you got to be ready to go. We're going to reset calculators. I'm going to give you your test. We're going to go because I want to make sure that timing is not an issue. If you come in late or you come in relaxed and you're not ready to go, I'm asking you to take like off the backs of your calculators, like all those things you know you're going to have to do on Thursday. Come prepared so that that doesn't have a problem when it comes to timing. Questions on expectations for these. So most of them I gave like 2 points to a line. So 2 points to domain, 2 points to range, 2 points to increasing, 2 points to decreasing, 2 points to constant, like that. So it added up. It ends up being like a 24-point question, okay? But it's broken down into its parts. All right, then came your transformations. You're going to get 2 where it says to give the parent function, describe the transformation, and then you're going to get 1 where it gives you the graph and you have to give the equation. So remember all your parent functions. If it's a parabola, it's f of x equals x squared. If it's an absolute value, f of x equals the absolute value of x, and that's a v. The square root takes that arc to the right, the cubic function goes up, right, down, left, and the reciprocal function is in the top right corner and bottom left. Let's just say it's quadratic, but it's pretty much the same pattern for all of them. What does a plus or minus on the front do? Flips it upside down, right? Or over the y-axis, or the x-axis, sorry. X-axis. Okay, the negative flips it upside down or over the x-axis. Reflection over the x-axis. The a, or the absolute value of a, because we ignore the plus or minus sign, if the a is greater than 1, what's it do? Good. Narrow or stretched? Especially with a square root, you don't want to use narrow because it makes it taller, okay? The square root, you could say tall, okay? Or be safe and say stretched because that works every time. If it's less than or in between 0 and 1, so it's a fraction, now this is going to flatten it out. It makes it wide. It's a vertical shrink or compression. You can use any of those words. If it's a square root, it flattens it out. The only time you guys would see a negative on the inside if it was a square root 1. And remember that this points it left. Or over the y. I did not do a negative underneath with a horizontal shift because remember that changes the direction. The h, or what's inside the parentheses, if it's positive, it shifts it left, and if it's negative, it shifts it right, the opposite direction that your brain thinks. And the b, which is your vertical shift, if it's positive, it shifts it up, and if it's negative, it shifts it down. And then you'll see something like this where it says to find the equation from the graph. So if this is a shift to the right 1, to the right 2 and up 1, and that's a square root, this would be f of x equals the square root of x minus 2, because that's the shift right 2, plus 1. So you won't have to worry about a non-grid stretch or shrink. But any other translation can happen, right, left, up, down, pointed, like reflected over the x-axis, that kind of stuff you could see on the graph, and then you have to give it. Questions on those? That was 1-4. And then 1-5, which is what we just did on the warm-up, okay? You have to be prepared for all of that. F plus G, F minus G, F times G, F over G, F of G of X, and G of F of X. And then the domains of those. So remember on these, we carry down F or G's domain. And then check for new. For these, we carry down only the function on the right. And then check for new. All right, I'll let you've got like 8 minutes. My advice is to work through this question. And really, you would want to take less than 8 minutes on your test if you could do it. So this is kind of a good, like, give you a pressure time situation, okay? This is kind of what your graphing calculator question is going to look like. Graph it. You only need to graph it on the paper for your own reference. Like, I would actually say it's probably a good idea to graph it and label your max and mins because that's where it's going to be easiest to determine your increasing, decreasing behavior. I am not giving points to can you draw what your graphing calculator looks like. So the graph on your test is not worth points, but it is your reference when you start to kind of like pick, like you can plot and label things. If you've already done this, if you went on over the weekend and you did this, then you can also open up your review. I posted it last night, okay? It is a lot. You don't have to do it all tonight. I would maybe pick and choose a little bit tonight, go back and finish a little bit more tomorrow. And I will post the solutions to that. I don't collect it because I post the worked out solutions, but it is obviously strongly encouraged that you complete that review.